Hi everybody. So welcome to your last section of video notes for Chemistry 101. Congratulations. You have made it through. All right, so for your last mini lecture, I actually have a very relatively short mini lecture for you. It is going to be about strong and weak acids and bases. So we have talked a lot about acid and base properties and what actually makes an acid or a base, all the way up until this point. And now what I'm going to tell you is just a list of strong acids and strong bases, and you're just going to need to memorize them. It's just one of the few things in this course that I just ask you to straight up memorize. Easy peasy. There's only 6 strong acids and 6 strong bases you need to worry about. So what does it actually mean to be a strong acid? Well, we know that acids are proton donors, H plus or hydrogen ion donors, right? So if you had an acid or a base, that acid is going to donate its proton to whatever it's reacting with. But if you were to think about what actually makes something a strong versus a weak acid, it's about how much that acid actually ionizes or how much it dissociates in solution. So all of the acids that you've worked with, all the acids that I work with, are actually dissolved in water. They're solutions. So if you were to have a strong acid, when you take that acid and you put it into water, we say that it completely ionizes. So you should remember this word ionize. What does it actually mean to ionize? You take something neutral, it's gained or lost electrons, and therefore it's going to have a charge on it, right? So in this case, a strong acid completely ionizes in solution. Let's add that in. So what would this look like in the form of an equation? So one of your strong acids is hydrochloric, HCl. So if you take HCl and you add that to water to make a solution, this thing is going to completely separate. It's going to completely ionize. All of the HCl is going to break up and you're going to form chloride ions in solution. And it's going to donate its proton to water to make the hydronium ion, H3O+. So, if you had, let's say, a 1.0 molar solution of hydrochloric acid and you added water to it, all of that hydrochloric acid is going to dissociate. It's going to ionize. So that means your final solution, you're going to have still a 1.0 molar concentration of those hydronium ions because all of the hydrogen and the chlorine broke apart from each other to form those ions. So this is what we mean when we say completely ionizes. Everything you put in, all 1.0 molar of it, is going to dissociate into H plus or H3O plus, remember, same thing, and the chloride Cl minus ions. So there are 6 strong acids that you need to worry about. Here is the list of them. You're going to write them down and you're just going to memorize them. You got HI, you got HCl, you got HBr, you've got HNO3, you've got H2SO4, and you've got HClO4. So this is hydroiodic, hydrochloric, hydrobromic, nitric, sulfuric, and perchloric acid. I guess I should write those names out for you so you could recognize them. Let me do that for you real quick. All right, so we got hydroiodic, hydrochloric, hydrobromic, nitric, sulfuric, and perchloric acid. And you would add the word acid at the end of each of these names. Okay, so oddly enough, I was on Instagram over break, and I saw someone who said that she was not good at chemistry, and so she came up with a mnemonic to help her remember the identities of the strong acids. And I was like, oh, how timely. So I will tell you her mnemonic. You can use it or not. There's only 6, so really I don't think it should be too difficult to memorize, but if you need one, here's a helpful mnemonic. So what she said was you start off your list of strong acids with hi. You tell yourself hi. And then you'll say, so what, Miss Lambert? Why are we learning about acids and bases? Chemistry class is boring. And then I would say, no, chemistry class is so fun. But if you're really worried about it, class is almost over. And then you add your hydrogens onto the front of each of these. You add a 2 for sulfuric. Everything else gets a 1, but you need 3 and a 4 there. So this was her mnemonic that she used to help her kind of remember the names or the identities of the 6 strong acids. Take it or leave it. Use it if you like it. If you don't, just memorize them. Okay, so back to acid strength. So the whole point of this is that strong acids will completely ionize in solution. So then what would make something a weak acid? Well, obviously it would not completely ionize in solution. So we say weak acids partially ionize in solution. So this brings us to equilibrium, which we started learning about earlier in this unit. For those of you who are just taking Chem 101, you don't have to worry about how to actually calculate a lot of things with equilibrium. For those of you going into AP Chem, equilibrium is huge. You're going to do so many equilibrium calculations. It's going to be so much fun. But for weak acids, they only partially ionize. So the way that we would write this is, let's say that we've got acetic acid, CH3COOH. This is one way you could write acetic acid. Remember that if you memorized acetate in the other form, it's totally fine if you write it that way. The reason why you typically see it written this way when you're talking about acid base is because you're donating a hydrogen ion. So typically you write this at the end because this is the hydrogen ion that'll pop off, that'll be donated when it reacts with something. So that's why I like to write it like that. So let's say you have a weak acid solution of like 1 molar acetic acid. You take this thing and you react it with water. You just try to dissolve it into water. So not everything here is going to ionize. So what we would say is some of the acetic acid is going to ionize in solution to form the acetate ion and the hydronium ion. But weak acids can actually go through an equilibrium process. Some of that weak acid will dissociate, and some of that conjugate base will react back with the hydronium to produce acid and water. So weak acids partially ionize, they go through this equilibrium process, which means that unlike with a strong acid, if you started out with a 1 molar solution of a weak acid, you're not going to have a 1 molar solution of hydronium. Instead, you're going to have less than 1 molar. Again, for those of you in 101, you do not have to know how to calculate the pH of a weak acid or weak base solution. For those of you in AP Chem, you will learn how to calculate the pH of a weak acid or weak base solution, but that's coming up for you down the road. You do not have to worry about it right now. So if you have a very, very high concentration though, let's say you have a super, super high concentration, not like 1 molar, we're talking like 12 molar. Let's say you had a 12 molar solution of a weak acid. If that thing is so highly concentrated, a lot of times effectively you can say that that weak acid will mostly ionize. So you kind of can assume that H plus will really heavily ionize, which means that at equilibrium in your weak acid solution, the concentration of your H plus will be equal to the concentration of A minus. So this thing right here, this is a way that you can write your conjugate base. So, we call it A minus because it was your acid, and then when it deprotonated, when it lost that hydrogen ion, what's left over is the conjugate base. So the acid just minus that hydrogen ion plus a negative charge. So we can use A minus as just like a placeholder to write the conjugate base. So this is true for high concentrations. Again, though, I am not going to make you do any calculations with these weak acid, weak bases. This is just extra information that I think is good for you to know. So, the strong acids and strong bases are basically the same definition. For a strong bases completely ionize in solution, just like our strong acids do. So in this case, let's say you had a strong base like potassium hydroxide. You took this solid and you dissolved it in water. What's going to happen to it? Well, it's going to completely break apart. It's going to completely ionize. It's going to form K+, the potassium ion, and the hydroxide ion. So let's say, again, you had a 1 molar solution of this strong base. Because it's completely ionizing, you're going to have a 1 molar concentration of that hydroxide ion after everything has completely dissolved. Just like with strong acids, the only difference here is because we're talking about bases, we're talking about hydroxides. So there are a list of big 6 strong bases I would like you to memorize. They are all a metal hydroxide. So hopefully all you have to do is quickly be able to memorize the metals that go with them, but all of them are just hydroxide formulas. I didn't come across a mnemonic on this on Instagram, but I guess I can do some searching. So you got lithium hydroxide, you got potassium hydroxide, you got strontium hydroxide, you have sodium hydroxide, you've got calcium hydroxide, and you've got barium hydroxide. So these are your big 6 strong bases. These are the ones I'd like you to memorize. So weak bases, you guessed it, exact same thing as before. Weak bases, partially ionize in solution. So one of my favorite weak bases that you all have seen and worked with is ammonia. So let's say you had some ammonia and you react it with water. Again, this is only going to partially ionize in solution. So some of it is going to go to form the ammonium ion, and some of it is going to go to form the hydroxide ion when this thing partially dissociates, but this can go back the other way in an equilibrium system. So if you had a 1 molar solution of ammonia, you will have a less than 1 molar solution of hydroxide. Oh, wait a second. Hold on. I'm realizing I wrote my alligator the wrong way in this one. You will have a less than 1 molar. Caught myself the last minute. All right, so why is this important? Let's consider these 2 solutions right here. So let's say you had a 0.1 molar solution of sulfuric acid and a 12 molar solution of acetic acid. So first start with thinking about what types of acids do you know these are. This thing right here, sulfuric, is on our list of strong acids. So this is a strong acid. Acetic is not on our list of strong acids, which means that this thing has got to be weak. Anything not on the strong list is weak. So what does that tell you about the amount that they're going to dissociate in solution? So for sulfuric acid, because this is a strong acid, this thing is going to completely ionize. Completely ionizes. This means, therefore, the concentration of hydrogen ions in solution will be equal to 0.1 molar because this thing is going to completely dissociate. If you know the concentration for sure, you should be able to determine the pH using the pH formula. So for this one, pH is equal to the negative log of the concentration of hydrogen ions. So our pH here is going to be 1. That's a very low pH, right? So if we come over here now, though, and we're talking about our weak acetic acid, this thing partially ionizes. What that means for us is we're going to have a concentration of hydronium ions that is less than 12 molar. But 12 is way, 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 way bigger, way more concentrated than 0.1. So our pH, while we can't exactly calculate it because not all of it is going to dissociate, so we don't know the actual amount that's dissociated, we can assume that it's also going to have a pretty low pH because this is a really, really high concentration. Why am I telling you this? Because there's two things that are really important that you need to know. One, you can calculate the pH of a strong acid or base solution, but you cannot calculate the pH for a weak acid or base solution. So, strong acid or base, if you determine that's on your list, you can calculate pH for it. If it's weak, you cannot calculate for pH for it yet. For those of you going into AP Chem, you will be able to. For those of you who are just taking SBCC, you don't even need to worry about it. But the second thing that's important about this is that pH and concentration do not assume the strength of an acid or base. I want you to be very, very clear on that. If you have something that's highly, highly concentrated, that does not mean it's a strong acid or base. If you have something that's a really, really low pH, that does not mean that it's a strong acid or base. It has to be, by definition, it will completely ionize in solution to be a strong acid or a strong base. And those are just the ones on the list that I've given you. So, these are the two most important things that you need to take from this. Please make sure you get all these notes written out. And then that is all you have to do. This is your last video lecture. Give yourself a little pat on the back. Give yourself a little brain break. And then go back to studying for your final. Okay, bye.